So we've been looking at applications of k-nearest neighbors and classification models. In our previous video, we looked at doing image recognition, we looked at denoising images, and in this particular video, we're going to look at recommendation engines. So we're using collaborative filtering. Essentially, if you think about there's products that you review, you rank, and then there's other products that you review. And so what we're doing is we're making recommendations. If one person liked this product and they like the other product, and then you come along and you like the first one, then we can recommend to you the other one because somebody else also liked it. So let's look at how we would build a collaborative filter recommendation engine. To do this, we are going to be using a data set. And you can get this data set. So the code and the data set can be found here at, at drstephpowers.github.io/BIA. And we are working in the workbook called KNN Use Case. You can find the data set here, video game data set. If you click on it, it's actually a link to my Google Drive because it is quite a large file, which you can then download. If you're not comfortable downloading it from my Google Drive, because yeah, you don't know me, then you can also get it from its original source. This video game data set is a portion of a data set from the University of California, San Diego. And so you can go to this original data, you can get the original data set here. It is reviews on video games from Amazon. And it's a 2018 data set. So if you are there looking at it, you can find it. I'll just show you in case you want to go there to get it. All right, we are looking at the Amazon product reviews. And we are looking at Amazon reviews from 2018. There are a bunch of them here. They're all really quite big. And so what I did is I'm doing the video games one that is much smaller. And in fact, we're doing the smaller data set video games that is ratings only because we only need the item user rating. We don't even need the timestamp. All right, so if you are downloading it from my Google Drive, or if you are getting it from the original source, you will then need to put that into your Google Drive. You will mount your Google Drive. That, of course, then ties your workbook to your drive so that you can pull in this data set here. In order to do that, we'll need to import pandas as PD. Then we'll call this data frame. This is going to be a CSV file. Wherever you put it into your Google Drive, that's going to be this part here at the front is going to be the same for everyone. I put it into a folder called BIBA Handbook and a folder inside that called Chapter 8. The file is called videogames.csv and it doesn't have a header. So put header equals none. So we're porting that in wherever you got it, whether you got it here from the University of California, San Diego, or whether you're getting it from the link that you found this particular sheet at. So here you could download it from here if you would prefer. So it's just this video game data set here. All right, so what we want to do is first look at the data set. And the data set consists of 4 columns, as we said. Those 4 columns are, according to the author, they are item, user, rating, and timestamp. To add labels or headings to this, we're going to take our data frame and do dot columns, and then we can provide the names, item, user, rating, and timestamp, and then have it just show now the top of this table now that it has these new headings. In order to do our recommendation engine, we are going to need to import CSR matrix. A CSR matrix is a compressed sparse matrix, sparse row matrix. In other words, it is a table, a matrix full of zeros. And that is because our users don't review every single item. So there's going to be a lot of zeros in this particular matrix. One of the first things we're going to do is create the CSR matrix in our process. So we're going to need to import CSR matrix from skippy.sparse, and then we're going to do our k nearest neighbors. We're going to use the one that says nearest neighbors. In our previous renditions, we have used, if I can find it, the k-neighbors classifier. We're actually going to use the one that is not called k-neighbors classifier, but is called nearest neighbors. This allows us to specify the distance measure, and we'll actually use a different distance measure, and we'll talk about that in just a minute. All right, so we have our table. We are importing CSR matrix and nearest neighbors, so let's do that. The first thing we need to do is create the CSR matrix. So what we're going to do is create a function we'll call sparse matrix, and it will take our data as an input. And then the first thing that it does in this code is that it is going to take the variable that is users, and it is going to find out how many unique users there are. So for example, if we change this out to you here, what we get is that in terms of the number of unique users in this data set, we have 1.5 million unique users. This next line of code here looks at how many unique items. Okay, so if we change this out to df here, show me m, we get that there are 71,982 unique products that are being reviewed. These are all video games here. Then what we're going to do is we're going to create a user map. And what this user map does is it takes all of those unique users, and then using NumPy, it's going to create a list of those unique users, and it is going to then assign a number to each unique user. So I'll just show you here. Take this piece out, user map, change out where it says data to our data frame itself. Okay, so here you have all of the user IDs, and you can see that it's given each one of them a number. And we do the same thing, just going to get rid of that because then I have to scroll through it. It's going to do the same thing for the items, create a list of the unique items and give a number to each one of those. Now, when we do this process, we're going to be looking up information on these tables in two directions. We might have the user name and then need the number, and we might have the number and need the username. So what we have here is two maps, one that goes one direction. This allows us to look up the user and get the number. And then we're going to create the same thing but flipped, and that is going to be the user number, and then we will get the name of the user, or the item number and then the name of the item. So we can look it up either direction is what these two lines of code are for. Now, the remainder of this function, user index, item index, and creation of a CSR matrix, what this is doing is creating a matrix that has the shape of the length of the number of unique users and the number of unique items. And it's going to populate this matrix with ratings. So let's actually just kind of look at what that looks like. So this is a compressed sparse row matrix that you see here on the left. I'll just zoom in here. So what does this tell us? This tells us if you are user number 0, so first column here, then you did not review the first item, you did not review the second item, you did not review the third item. If you are the second user, so index number 1 here, then you did not review the first item, index 0, or the second, but you did review the third. Okay. If we look at the third user, index 2, they reviewed the first item and gave it a 2 on the rating scale, and they reviewed the second item and gave it a 3 on the user scale. So again, because users don't rate every item, there's lots of zeros, so it is a sparse matrix. And what we have here is that the numbers represent the ratings, but the matrix represents the unique items and the unique users. So when we're creating this matrix using our function here, what we're doing is we are taking the user index. So here's our list of unique users. Here's our unique list, our list of unique items, and we're creating those as the two parts of the matrix, and then we're filling it with the ratings here. That's what these 3 lines of code are doing, are creating that matrix. Now, when we do this, we want to output the matrix, the CSR matrix. We also want to output the user map, the item map, and the inverse of those so that we can look things up either direction. So let's create that function. And then we're going to apply it to our particular data set, which we call data frame. That is the new table of the video game ratings. Remember, it has 3 columns here: item, user, rating, and then it has timestamp, which nobody cares about. We call this table DF. So here we have our different variables. So what we're going to do is we're going to create that sparse matrix from that data. Now, when we call this function is going to create the matrix, and it's going to create a couple different lists here. And actually, it's going to create a couple different dictionaries is what it's creating. We can see that here, dictionaries. So it's creating these dictionaries so we can look things up. We want to make sure that when we call this function, the output is labeled. So take whatever it returns and put it here to the left of the equal sign so that when it outputs that information, you have a name to call it so you can use it. Otherwise, you won't know what it is. So make sure this list here matches this one. All right, let's do that. So we have our sparse matrix. The next thing to do is going to be to set it up to find similar items. So what we're going to do is have it look for where things are on this CSR matrix and then find the nearest neighbors. So we're going to create a function called find similar items. You're going to provide it with an item ID number. You're going to provide it with that CSR matrix, and we're going to designate what is K. How many nearest neighbors are we looking for? So here we're going to create an empty list called neighbor underscore IDs. Then what we're going to do is take that item ID, look up on the item map its number, that'll be our item index here, and then go to that CSR matrix at that location, okay? And then what we're going to do is we're going to look for the K nearest neighbors next to it. Now we're using nearest neighbors classifier. We're going to specify K here. Now the metric we're going to use is cosine. So when we have done K nearest neighbors before in that K neighbors classifier, it does Euclidean distance. Straight line, how far are the data points from each other. What we're going to look at in this particular model is cosine similarity. So here we have 2 data points. Rather than looking at the direct distance from them, what we're going to look at is relative to some origin, what is the angle that separates them. So if we're going to take our matrix here, our CSR matrix, and we have points on the CSR matrix, what is the angle that they are relative to each other? Okay. All right, we have this. So we're going to call it, we're going to fit it. And what we're going to do is we're going to have it find the nearest neighbors to it. So find the data points that are nearby. And then what we're going to do is we're going to loop through. So if we're going to do 10 nearest neighbors, for example, we're going to loop through those 10 nearest neighbors, having it pull information about each of those neighbors. Okay, and it's adding that information to this neighbor IDs list. So let's show you how that works by first entering that function in, but then let's run it. So let's say item ID here, and we're going to say find similar IDs using find similar item function. That's this right here. And then it's going to use the item ID we just gave it. It's going to use our CSR matrix we created previously, and let's do 10 nearest neighbors. When we do that and output the similar IDs, you'll notice here it has given us 10. And so this loop right here is taking it and looking up on that inverse map it is finding the names of those items based on its location from the CSR matrix. Okay, so it's going the other direction, which is why we need that inverse map and the map itself. So now we have a list of the 10 nearest neighbors data points to the ones that, or to the one that we've given it. Now let's turn that into a recommendation. So what we're going to do is we are going to create a function that will recommend items for the user, and it requires the user ID. It is going to require our CSR matrix, and then we're going to need a user map, an item map, and the item invoice map. And these we actually called map here, and here, remember, these are placeholders, so you can call them whatever you want. We're just putting them in the same spots here. So this needs to be user map, item inverse map. Okay, and we can specify K here. We should specify it to match what we had before. You could leave it out just as K. Make sure then you have it when you call that K equals 10. The two need to match, right? We have 10 items here. When we did our find similar items, now we're going to need to do that same 10. Okay, so what we're going to do is we are going to take our original data frame and we're going to filter it so that we are looking for the user that is the same as the user ID. So just take that whole data set and find a specific user. Then what we're going to do is we are going to find the ratings from this data set here, this new revised one that's just that user, and we are going to find what they rated. So we're looking here at the maximum rating for an item. And then what we're going to do is we're going to find similar items that have that same rating. Okay, so we'll look at what are the things you liked the most as the customer. So here's a list of all the games that you have reviewed. Which game did you rate the highest? All right, so we find that item. And then what we're going to do is we're going to find the nearest neighbors to that item. So find the similar items, and that's what we're going to return. So we're looking at the ones that you rated the highest, and then we're looking for what is near it in terms of what others rated, also rated. Okay, so let's then do that. So you'll notice that this function is going to actually call this function. Okay. All right. So let's do this. And what it's going to do is it's going to print out, since you watched whatever item, then you might also like, and then it's going to provide some other items. So let's give it a user ID. So let's assume that this is us here. Here's our user ID. And we're going to have X is going to be our CSR matrix. We have our user map, our item map, and our item inverse map. And we have that our K equals 10. So since you watched whatever, that's the one you rated the highest. If you're this person, you might also like, and then it's going to give you 10 others that are a near neighbor on that matrix. So we can actually look up here if we had, so let's say our table contained, actually let's just look. So here we'll look up this one here. We'll look up this user. We'll look at its location on the map here. And so we can see this user here. This is the item that, that they rated. They gave a 4 rating to. So this is the only time this particular user appears in the table, and they gave that rating a 4 to this particular item. And so what it's telling us is that you rated this particular thing, and we have it as watched, but the video game you played, you can have it say whatever you want. Since you played or bought, right? Since you bought this, you might like this other one. So here we have this person, we can look them up, and what we see is that this is the item they rated a 4. So what it's doing is it's looking for other things that other people also who rated this one out of 4, what else did they also rate? Okay, is what it's looking for. All right, so here's our recommendations. And in this case, that's all the information there is in the table. If we had a secondary table, we could look these items up and get the names of the actual products and not just, these numbers or codes here. Let's try a different one. So this is a different user ID. And so if we put in this user ID, of course, it's not happy because this should actually say user map, item map. Got to be consistent in our naming here. So this person, it says, well, you bought this item here, so you also might like these particular ones here. And we could look them up, right? We could see what it is they did. Put our quotes around it. So we can see that this particular person, the only item they rated was this one, and they rated a 1. So then what it's going to look for is it's going to look for other people who rated this product low. I guess in this case, what we need to do is have it say these are the items that you're going to hate, because if you rated 1 on this particular item, then it looks like you're probably rating 1 on these other items as well. So we have to be careful in terms of our system, put some additional constraints in that we're only going to recommend or complete this process when the ratings are above a certain amount. Because in this case, this person only rated 1 item and they rated it a 1. So remember, it's going to look for the maximum rating that this individual gave. So you're assuming that a person is going to rate a bunch of products, and some of them they'll like and some of them they don't. And that it will then choose the ones they liked and use it to find other ones they'll like, as opposed to here, they only rated 1 item, they hated it. And so, of course, it's going to then recommend to them more items that they're going to also equally hate. So we have to be careful in our system that we recognize that there's a limitation here if they only rated 1 item and it had a low rating. So try a couple other data sets here. At that same website we were at before, you can get another data set, this one on pet supplies. So again, use the 2018 data set, small set, with the just the ratings. So it's set up very much the same as the video game. So you can use very much the same process. So play around with that. The difference here is that it is the formatting of the file is a JSON. And so to import a JSON, you need to import JSON as a package. And then you'll need code that looks like this once you have saved that JSON to your drive. And you can get the file, again, you can get the file here at Pet Supplies Dataset. It is a larger file. Just download it if you want to download it from my Google Drive and put it into yours. Alternatively, you can go to the original source here. It's the 2018 data set that is just the ratings, and it's the smaller data set. So you can pull one of these or go there and play. They have lots of them, lots of great data sets. So go find one, pick one on the smaller side so it doesn't take forever, and you can put it into your Google Drive. This one's in JSON format, and so you do need to import it in, and JSONs have to be treated a little bit differently. This one here has that the format is 1 review per line in JSON. You have to know how it's actually been put into the JSON. And so here we have JSON.loads as lines because that's the way that it is formatted. So you're going to do 4 line in open, and then from your source, it's going to be R for read as opposed to like write. And then you're going to append it to this empty list you've created where you're going to load it by line. And then you're going to normalize it. This will get it all set for you so that it looks like the standard data set that you're used to. Really, you just need the overall rating of the product, the ID of the product, and the ID of the reviewer. So you can just pull reviewer ID, the overall, and the number for the product, and then you can use the same method that we just did. You can also find, here's another data set you can play with as you're building your collaborative filter. This one is a movie reviews data set that you can get from this source here. In this case, it is going to be a CSV file that has 2 pieces, and you can get the data set either from the original source here, or you can go and download here. There are 2 pieces to it. We have the CSV file that is the labels, and then we have the CSV file that is the reviews. And so in this case, what we'll do is we'll need to read CSV to bring it in. And this extra piece here allows you then to add one more step to your process, which is after you build your recommendation engine based on user ID, movie ID, and rating, you can add a lookup process where it takes those movie IDs that it recommends and you can turn them into titles. And so instead of just saying we recommend movie ID number 3, you can say we recommend Jumanji. Okay, so try doing that and adding that last step to the process in terms of having it look up the actual name once it's determined what it recommends.